Hi. Today we're gonna solve the exam for really advanced macroeconomics. It's actually dynamic macros, so it's a grad level type of exam, type of questions. So yeah, let's get to it. So the preamble for the questions is: consider a version for the RBC model. This is the real business cycle model with the stochastic preferences for leisure. So we're adding leisure to the model. The rep consumer maximizes expected utility that we have like over here, right? And actually, this shock it has to be accounted for. So yeah, let's actually have a real simple explanation for what the shock is, right? So subject to the budget constraint and the usual law of motion of capital. So as we're adding leisure to the model, we actually have a law of motion for leisure or labor, if you will. It's actually the opposite of leisure is labor. So yeah, we have to add that to the equilibrium. So yeah, and the weight of leisure in utility is a random variable following the autoregressive process. So that's an AR1 process. It's just 1 degree of the AR. And we have it defined thusly, right? And where this epsilon is in normally distributed random variable, right? So it's continuous. Continuous. So this is actually important because we're gonna be adding integrals to the equilibrium because of this normally distributed random variable and the probabilities it implies, right? And with mean zero and variance sigma gamma squared. In words, consumers are in some periods lazy, while in other periods they like to work a lot. Okay, so this is accounted for epsilon gamma, right? Epsilon subject to time and gamma. On the other hand, the representative firm produces output using the constant return to scale production. This is actually a Cobb-Douglas one. Production function, and we are experiencing shocks by this component right here, and it's also an autoregressive process defined by this function right here. Let's mark it down in blue. Okay, and it's another normally distributed. So we're actually adding two integrals to my equilibrium, right? And well, first question is using the contingent plan's sequential notation. This is important. Contingent plan sequential notation. Write a consumer's problem for this economy, right? You don't need to write the whole definition of the equilibrium, just the consumer's problem. Okay. However, be sure to define explicitly expected utility, and don't forget the condition of restricting time devoted to work. Okay, so what is the consumer's problem? So we have to start from something, right? And that's the initial level of capital. So given initial level of capital, let's call it K0, and it has to be positive, and we need the technological shock, right? That's set T, and gamma 0, right? That's initial conditions for the shocks. And well, these shocks are affecting actually my prices, right? So my wages are going to be a function of the shocks itself. Let's mark it down as super index and gamma T, right? And my rate of return of capital, that's RT, is also going to be affected by these external shocks, or these shocks, if you will. And the processes CT gamma T, right? Or, well, the processes are just C and gamma, right? Because we're defining the process. And contingent plans, well, also consumption is going to be affected by gamma and the technology shock. So leisure and technology shock. Labor is going to be affected by these shocks too. And well, interest is going to be affected by these shocks, and also capital. So that's set T gamma T, right? So these contingent plans solve the following maximization problem, which is the consumer's problem. So we want to maximize, right, the expected utility, and let's well, expand this. All right. So we have an expected utility right here. This is my expected utility. So what do we want to do? So expected utility, it's a sum, right? From T0 to infinity of beta T, right? But we have two shocks affecting this the contingent plans, right? So as the errors or epsilons are continuous in this case, we are able to take the integral of CT element of the aggregate, and that's gamma T element of gamma T, right? Over the probability of experiencing that shock, that realization of the shock. This is just the probability of experiencing this particular shock, right? Okay, so, and we also have to multiply by the probability of experiencing the leisure shock T, right? And well, now we can add our utility function, which is this one, right? And this is just consumption. Okay, so this is times log CT, and I'm gonna mark it as let's just put the empty parenthesis to mark down that it has to be affected by these shocks. Okay, so yeah, don't be confused about that. And plus is just to save some space, gamma T, right? Log, and well, we want labor, we want leisure. This is leisure, right? 1 minus LT, because leisure plus labor has to sum to 1. So this is 1 minus LT, which is affected by the tech shock and the leisure shock. And well, finally the differentials over set T differential over gamma T, right? Such that well, we have to add the budget constraint, which is CT, contingent plan CT, affected by tech and leisure shocks, IT, affected by, we already know, and well, we have to, that's labor income. So this the real wages times labor gives me the labor income, plus RT, which is affected by these shocks, times capital, which is affected by the previous realization of the shocks, right? So I'm gonna add this one so you're not confused. This is return on capital. And then law of motion of cap. This is KT plus 1. This I'm gonna put the shocks here, gamma t, so you won't get confused. 1 minus delta is just the discount factor, KT, which depends like in this case. So Z t minus 1, gamma t minus 1, plus the investment rate, right? CT gamma t. Okay, and well, we're missing something, and that's the restricting time devoted to work. This is the law of motion of the law of motion of labor. It's not actually the law of motion of labor, but it's just the restriction on labor, right? So it has to fluctuate. Restriction of labor. So it has to fluctuate between 0 and 1. So LT, ZT, gamma T, and 1. And this has to happen for every T and for every realization of the stochastic processes. Right? And here we are. We have question number 1. Okay. Please be tune in for the next questions. Okay. Thank you.